Hello, this is Semantic Web Technologies, Lecture 1, the Web of Data, Part 4, the limits of the web. In the last lecture, or in the last part of the lecture, we have dealt with the question, what's the importance of meaning? And we have seen that in the web, meaning is not formally represented, but it's implicitly given within the natural language text of the web documents. And the language to represent any document on the web is HTML, and this is a simple markup language that only denotes the form and the representation of the document, as well as the links among the documents and the information within the document. But it does not denote and represent the meaning of the information, which is rather important because the web is huge. It is really huge. And we will now take a closer look on the problems that arise by the fact that the meaning is not represented in the web. First problem, just look at information retrieval. We all know that without Google we would be lost in the web. But what happens if we are looking for something? For example, here we want to look for Jaguar. But as you know, the term Jaguar has several meanings. So in the result of the web page, there will not be only results that are related to Jaguar the car, but also results that are related to Jaguar the cat, the animal. So the problem is that here the term Jaguar has several different meanings, and the search engine, it means in information retrieval, it is not clear from the simple term Jaguar which meaning should be represented or meant by that term. So this is up to the user. So traditional keyword-based search leads to many not relevant results when you have in mind, for example, Jaguar the car, and you will receive also additional results for Jaguar the cat. This fact is called polysemy. And also, if you have this information in different contexts, it can, again, represent different meanings. And this is not available for the search engine in traditional keyword-based information retrieval. So this is one of the problems that arises. Nevertheless, if you are looking for Jaguar the cat, maybe you will not get all the results that are really representing Jaguar the cat or that are related to that term, because for one and the same thing, you can use different terms, different words, different symbols to represent this one unique meaning. So for example, for Jaguar the cat, you can also take the Latin name for that cat. This would be Panthera onca. And only if you take this Latin term too, you will get answers or results from the web where Jaguar the cat is referred to as Panthera onca. So this means traditional keyword-based retrieval that only looks for the term will only give you result of documents where this term is present, and not results where the same thing, the same concept is denoted by another term, by, for example, a synonym, or when it's described in the form of a metaphor. So you see, in information retrieval, we have two problems because of the lack of explicit formally available information and semantics. We have the problem first that all our search results are spoiled by answers that are not necessarily related to the meaning, to our intended meaning of the search. And secondly, we will possibly not get all the existing answers because of synonyms and metaphors. So language in itself, because of its polysemy and because of the possibility to use different terms that have the same meaning, this is a problem for traditional information retrieval, especially in the web when we have, or when we are dealing with billions of web pages and these huge amounts of information. So this is problem field number 1. Consider a second problem, information extraction. We have already talked about that. So consider a web page like that with Japanese writing, and you are not able to speak Japanese. So what does the information represented within that page really mean? We have no idea. And it's the same for the computer. If the computer wants to extract information over the air, he has no idea what it really means. Or just consider the information represented on the web is simply a picture. So what does the picture mean? So here in general, you would have to apply visual analysis to consider what is depicted inside the picture. So again, talking about Google, Google solves this problem because all the pictures on the web are usually embedded within web pages. And in those web pages, of course, these pictures most times are described. And this textual description gives information about the image content. But when you have only the image, then of course it's difficult to interpret its meaning. For example, you also can consider that you have an image of a text. Then for us, of course, it's obvious we can read the text, but the machine not necessarily can read the text within a picture. So this is really difficult there to get the information out of the web page. So this can only be solved correctly by a human agent. So for example, you have no idea how the information really is distributed over the page. So if it's heterogeneous and in what order it is on the page. On the other hand, a software agent does not have sufficient information. It does not have sufficient knowledge of the context. It does not have the world knowledge and the experience that the user has to interpret this. So it is not able to solve the problem of information extraction without having explicit formal semantics available. And again, natural language contains a lot of implicit knowledge. For example, if you look at that picture, maybe these things, these accessories somehow are familiar to you, and you might think probably of Sherlock Holmes if you have read the novels or seen a movie. So the thing is that we can take clues as humans, and out from that use, we are able to derive, via logical deductions, new information from the available information. And this is also something, this is only possible if the information that is available is formally and explicitly defined in terms that make it possible that the semantics can be read and understood by the machine. Otherwise, we cannot deduce new knowledge from the available knowledge. So this is also, or belongs also to the part of information extraction, and this is problem field number 2. Next problem, let's think about maintenance. Websites tend to grow bigger and bigger, and there are really huge websites on the web. Just consider these huge e-commerce portals like Amazon, for example, or eBay, or just think of Yahoo, which was another search engine or a portal where lots of information was available. And the problem is, the more complex, the more voluminous a website is, the more complicated, of course, is the maintenance of this data. And the data in the website is only weakly structured. It means most of the information, of course, is contained in terms of natural language. And then you face the problem of consistency, or better, inconsistency. What does it mean, inconsistency? So syntactic inconsistency of a website means, for example, you have a link to another website within your document, and now the other website where you link to is moved away. So the link address is changing. Then, of course, your old link doesn't point to the new website. And the problem is then, of course, you will receive an HTTP 404 error. It means the website is not available under that link. This is a so-called syntactic consistency error, and you can solve this, or you really can recognize this fact, because simply you will receive an error message from the HTTP protocol. On the other hand, what is much more difficult to solve is the so-called semantic consistency error. What does that mean? Semantic consistency, just consider you have a link to another web page, and in the text surrounding this link, you describe the content of the other web page and say, for example, you link to a specific book. But now the content of the web page you are pointing to is changing. For example, there is not the book described, but now they describe the movie from the book. And then you have a semantic inconsistency because the description on the first web page does not fit the content on the web page it points to, because the content has changed. And here it's also difficult, really difficult, to determine in an automated way that these changes really mean a change in the sense, in the meaning of the information that is represented here. So to detect semantic inconsistencies is really, really difficult. And to do this or to solve this problem in a correct way is difficult to maintain, and also in a timely way, so that these changes and these corrections can be made in time is rather difficult. So maintenance is the problem field number 3. But it doesn't end here. We have another problem, and this means personalization. The information you get in the web, sometimes today, it's personalized. Of course, you know that. When you are looking or searching at Google, and you have a user at Google, you have a username and a password, and you have an account there, then of course most of the information that you access is logged in the log files, and because of the usage patterns you have there, then the search engine is able to adapt to your way of searching and to adapt the search results to the way you are searching. So this is simply personalization based on log file analysis. This can be done for any user. Also, if you have not a user, when you stay on a web page and when you stay there with the help of cookies, it is possible to recognize who you are, at least when you have already visited this web page, and then your actions can be retrieved from the log file, and then personalization can take place. This means when, for example, 2 different persons make the same search on Google, they might get different results that are determined by their search behavior beforehand. But on the other hand, to make it really personal, the problem is, where do we get all this really personal information? Because if you analyze the log file, you simply assume that what you have looked before is also relevant for your next search. So it means it doesn't take into account the context of the user. Maybe the user looks up information for somebody else, then he represents, or this search represents the search of somebody else and not from the user. And the user's intention is not, or the search intention is not the same intention that the user really has, because he's looking for somebody else. So the problem is where to get the real information. It means where to get the information what the user really intends to do. You can get this, for example, if you force the user to answer questions beforehand, but this is not a way that is really usable, or that is, let's say, convenient. So the problem is personalization on the one hand, and on the other hand, maybe you do not want the search engine or the web to know about your personal preferences, about your personal information. So this data, of course, has to be secure. You do not want to get everybody, or you do not want to have everybody access to that information. So personalization stands versus data security. So this is the problem part number 4 that can be much better solved if semantic information about the context I am accessing the web would be available. So just remember the 4 exemplary problems that we face if we don't have access to the semantics of the information. First is information retrieval, second was information extraction, third was maintenance, and number 4 is personalization. So the big question is, what can we do for now? Because the web does not contain explicit semantic information. Is it all over? Or how should we solve that? And of course, you might have guessed it, the name of the lecture, of course, is Semantic Web Technologies. The semantic web is one way to express formally the meaning of the information given within the web. And in the next part of the lecture, you will see how this could work and what does the vision of the semantic web mean.